Hello, this is Mr. Cruz, and this is your flipped classroom video, and today's lesson is on acceleration. And the first thing I want you to do is to look at the car at the bottom. I'm going to kind of wiggle it around here. And I want you to ask yourself, when I move it across the screen, if it's moving at a constant speed, or if it's accelerating, or if it's decelerating. So let me move it here. Ready, go. Okay, if you said that it was moving at a constant speed, you were correct. And what was happening there was at every single second, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Every single second, it was covering the same distance, and so its speed was constant. Maybe it was going 1 meter per second the entire time. Okay, let me do that again. So this is, oops, here we go. Whoops. There we go. Here we go. Ready? So it's moving at a constant speed. Now let me show you what would happen if it accelerates. Okay, you can see its speed increased, and then if it decelerates, that was deceleration. So we need to kind of understand these concepts at a different level. Using some numbers, we can do that. And the next card is going to show you a plane taking off, and you can see on this, at 0 seconds, the plane was going 0 meters per second. So this is the velocity, and this is the time. Okay, you can see the units meters per second for velocity and seconds for time. So 1 second later, the plane was going 8 meters per second. And you can see the amount of distance that it covered by looking at the two pictures here. And pretend that a photo was taken every single second. At the 2 second time interval, the plane's speed increased from 8 to 16 meters per second. And you can see that it covered more distance this time. And at the 3rd time interval, you can see that the plane's speed increased from 16 meters per second to 24 meters per second. So the question is, what is the acceleration? Well, it's all about looking at the patterns here in this particular picture. It went from 0 to 8, from 8 to 16, and from 16 to 24 meters per second. So every single second, this plane's speed increased by 8 meters per second. So we can say its acceleration was 8 meters per second per second. Now, this unit is a bit different. It's a unit of velocity over a unit of time. So you can see that every single second, the plane's speed increased by 8 meters per second. Okay? And so the plane was accelerating. And you can visually see that because of where the plane was each second. Each second it covered more distance compared to the previous second. Yeah, that's a lot of writing on there, but hopefully you can understand that concept. Now let's look at a different one. And this is a picture of deceleration. Because you can see here that the car, let's say this is at 1 second, this is at 2 seconds, and this is at 3 seconds, and this is at 4 seconds, and this is at 5 seconds. So from the 1 to 2 second time interval, the car covered this amount of distance. But at the next time interval, between 2 and 3, the car covered less distance. And between 3 and 4, the car covered less distance, and 4 and 5, even less distance. So the car was decelerating, it was slowing down. Here, maybe it was going let me make up some numbers here. Let's say here it was going 50 kilometers per hour, and then let's say here it was going 40 kilometers per hour, and here it was going 30 kilometers per hour. What would be next? 20 kilometers per hour, and then here it's going only 10 kilometers per hour. So this is its velocity, okay, and these are the times. So see if you can figure out the car's deceleration, the actual rate. Now it's going to be a negative number, because if the acceleration has a negative value, that means it's decelerating, it's slowing down. So it looks like the car's speed decreased by 10 kilometers per hour. So we're going to put negative 10 every single second. So its rate of acceleration was actually a negative number, which is deceleration, and it decelerated negative 10 kilometers per hour per second. What that means is every single second the car slowed down by a rate of 10 kilometers per hour. Okay? Now, for an object to accelerate, it can be doing one of three things. One, it can be speeding up, and we talked about that with the airplane. Two, it could be slowing down. We talked about that with the car. And the other thing that defines acceleration is when the actually acceleration is by definition a change in velocity. That's the definition of acceleration. So if you're speeding up, your velocity is changing. If you're slowing down, your velocity is changing. But remember, velocity also deals with direction. So even if an object is moving at a constant speed, it's accelerating if it's turning. So I want you to think of a carousel. A carousel spins at a constant rate. It goes around and around and around and around at a constant rate of speed. But by definition, the horses on the carousel are still accelerating because they're constantly changing direction because they're turning. So if you are, number 3, changing direction, you are also accelerating. Okay, so to sum it up, acceleration is a change in velocity. We can often feel this, like think of Test Track. You know, when you're sitting there in the car at Disney and Test Track at Epcot, and then the car speeds off, you feel the acceleration because you get pushed back in your seat. Okay, and then when it makes that big banking turn, you can feel the acceleration because you kind of get pushed one side because of the force of the going into that turn. And then when you're slowing down or decelerating, you can also, you know, a lot of times your body jerks forward. That's why we wear a seatbelt, because if you decelerate too fast, you know, you can get injured because your body's being jerked forward. Because the car's slowing down, but your body doesn't want to, so you lurch forward. So you can feel accelerations when you're driving or on a roller coaster ride. And all it is a change in speed or a change in direction. And that's your lesson today, and hopefully some of the activities that we do in class and some of the do-nows and the book will help reinforce these concepts. And I will see you in class.